All right, for homework 927, for those of you who want to make up your 200-point quiz, even though it's listed as 20, it's really a 200-point quiz. If you do all this work, copy all the words, copy the graph, copy all this work, and write down the 5 words to show me that you listened, I will automatically give you your 200 points. But here we go again. I want you on a piece of paper to write all of this, each of these 7. I want you to write all these words. All right, so here we go. Hopefully at this point you have written these down. But again, I need you to recognize, based on what we're looking at here, this one, Lucky Joe, is not tripling his money, not doubling. He's just finding the same $5 each day, which makes it linear. If he was doubling his money, tripling, exponential. But just finding the same amount each day, $5 each day, linear. This is discrete because he's waiting until the next day to find his next $5. And of course, D is 5. For writing the equation for this one, the 0 term is 30. And if I add 5 to that, the first term is 35 if I use that to write the equation. All right, the next one. This bank one is not charging a percent, so it's not linear. It's $6 each month. Because Sally's waiting for that bank to put that $6 in each month, I consider this linear because it's not a percent and discrete. Those exponential ones with the percent that the bank's paying you, they're constantly paying you a little bit more each day, so that would be continuous. But this one, waiting each month, discrete. This D is 6 being added each month. The 0 term is that 500 that you're starting with. After 1 month, you'll wait, and then you'll have 506. All right, next one's a little tricky, but what I want you to do for this one is compare 60 divided by 6, which gives her $10, or I'm sorry, that should be $10 per hour. 80 divided by 4 gives her $20 per hour. If you could fix that on your paper and make this $10 per hour. But either way, $10 per hour, $20 per hour, since those do not match, I don't care how much she has in her wallet, this is neither linear or exponential because of those changes. If it was both $10 or both 20, then it would be okay. Number 4, this one, person's going up by 3, going up by 5, and then going up by 2 again because none of those are equal amounts. Nothing to do with times. That's neither linear or exponential. Okay, the next one, 3 to 7 going up to 4, 7 to 11 going up by 4, 11 to 15 going up by 4. That equal amount each time, linear, not timesing, linear. This walking constantly would be continuous. And then the amount of miles you're adding each hour, 4, that would be your common difference number, D equals 4. If I had a 0 term, that would be that 3-mile distance from home I'm starting. And then after 1 hour, I'm now 7 miles away. All right, 6, automatic percent, exponential. Anytime you see a percent or doubling or tripling or halving, timesing, exponential. This one, because it's being filled by a bucket one at a time, a gallon bucket, and not a hose, this would be discrete. And then the R number is 4% added to 1, or 1.04. All right, the 0 term would be that 30 gallons you're starting with. And then if I take 30 times 1.04, using my calculator right here, that's why the little pause, that gives me 31, I believe. $31.20 or 31.2. Next one, 14 gallons for every hour, same amount every hour, linear. This would be filled by a hose, so this would be continuous. Because I'm draining my D number is going to be negative, not positive. Be careful. Don't put positive always. If it's going down, negative. If it's going down by 1%, this would have been 0.96. So again, D equals negative 4. And then my zero term is how much originally in the pool, 400. After 1 hour, 4 gallons later, it goes down to 396. It's down by 4 gallons. All right, the first word is blue. Blue. All right, so again, I need you to write all of these words and this information. Next part, I'm going to take this and shrink it and move it right here so I can use this as reference to kind of show you what I'm doing right here. But again, all this information is going to let me group these by similarity and then list from least to greatest. So linear, all my linears you could see were number 1 was linear, number 2 was linear, number 5 was linear, and number 7 was linear. So 1, 2, 5, 7 go in that first linear box. Those are all linear functions, linear equations. Exponential, for this set, there's only one of them, 6. Neither, this set has 2 of them. Problem 3 and 4 are neither linear or geometric. Discrete, you can see, waiting for the money, waiting for the bank to put the money in, filling it up one bucket at a time, discrete. So that would be 1, 2, and 6. And then my continuous, again, continuously walking, a hose continuously pouring water, 5 and 7 are continuous. Rates of change, I'm going to compare my D numbers, which always are the least, and your R numbers always the most. Straight lines will never have as great a rate of change than those curved ones. So all my low common difference numbers, my lowest is negative 4, which is problem 7. The next lowest is this D equals 4, which is problem number 5. The next lowest is this D equals 5, which would be problem number 1. And again, that's where I'm getting these 7, 5, 1. And then D equals 6 would be this situation, problem number 2. And then the highest is this exponential one, R equals 1.04. That is number 6. Notice I did not put any of those neither ones in there. Neither does not apply to discrete or continuous, so don't put 3 or 4 in any of these. Don't try to rank 3 or 4. They don't match the other ones. And then again, know that this line, even though this will be steeper at first, this one starting gradual will eventually shoot up like those exponential graphs do. All right, the second word is whale. Whale is the second word. All right, next problem here. I'm going to write the equations, but again, I'm going to try to paste in there the work that you could see, because I'm having you do it for number 1, where you have the D, you have the zero term, the first term, and number 6, where you have the R term, and then that being times by 1.04 gives me the first term. So here I go. For number 1, since it's linear, I'm going to write all 3 forms of function, 2 explicits, recursive, but then also slope-intercept, point slope. So this one is f of x equals that 5 times x plus the zero term 30. The next one, shifting over 1, is 5 times parentheses x minus 1 plus 35. And then the recursive, f of x equals f of x minus 1 plus that 5. But since this is linear, I need to also write slope-intercept and point slope. Slope-intercept is just replacing that f of x with y. Same slope, same y-intercept. Point slope a little harder. You need a point to plug in, so sometimes it helps to make a little table 0, 1, 2, 3. Starts out at 30, and then it goes up by 5, 30, 35, 40. This will give you an idea of which points you could use to plug into point slope. You could always plug the 0, 31 in. I'm going to choose this point right here, 135, which has the coordinate x is 1, y is 35. So I'm going to plug that into point slope form, which is always y minus the y coordinate number 35 equals slope 5, and then open up parenthesis and put this x minus this x coordinate number right there. That is point slope form right there, with the y and the x here always staying the same, but from the coordinate you choosing, the y number goes here, x number goes right there, slope number right there. But again, you can see all those forms, both forms of explicit, the recursive form, slope intercept form, and then point slope form, knowing that if I distribute this and add 35, I will end up right back at this slope intercept form. The next one, geometric, f of x equals the 0 term 30 times r to the x power, or go over to the first term and I get that 31.2 by timesing 30 by 1.04. Gives me 31.2. Again, telling you where I got that 31.4 by timesing the 0 term times 1.04. Gives me 31.212 times 1.04 to the x minus 1 power, and then recursive times 1.04. Know that for these geometrics, never will you have slope intercept or point slope form. There's no common slope that's the same. You can't use those equations. The third word is white. White. Okay, for this one, again on your paper, hopefully you have graph paper. I want you to graph this best you can. Where this is 0, 6. This is going up by 2s, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, going up by 2s. So I want you to be able to find the slope two ways, by making a triangle, realizing this is miles per minute. But you got to be careful, because this one looks like you're going over 1, but that's a mistake. For this graph, each box being 2, that's really a run of 2 and a rise of 2, 4, 6, 8. So this slope would really be 2 and 8. And if I divided those, that would give me 8 divided by 2, which is 4, or 4 over 1. But know that that's 4 miles per minute. This is miles per hour. Or I could take the coordinates 22 minus 6 divided by 4 minus 0 to get 22 minus 6. 4 minus 0 is 16 over 4, which is also 4 miles per minute. But if I convert that to hours, times this by 60 minutes for every 1 minute. I'm sorry, 60 minutes for every 1 hour. If I times that, the minute units will cancel. Times straight across gives me 240 miles per hour. And again, this one is in miles per hour, so once I find my D or my M, I'm good to go, ready to compare. The one way I want you to do it, this way, I want you to write this. Adding D, 2 blank spots gives me 3 of those unknown D's. So 50 plus 3D equals 800. Take away 50 on both sides, and that will give you 3D equals 750. The fourth word is dog. Dog. So if I divide 750 by 3, it gives me 250, and that's automatically miles per hour. So again, that 250 is miles per hour. Or you could take the 800 minus 50 divided by 5 minus 2, another way to get that slope, gives you 750 divided by 3, which is 250 miles per hour. So you can see this one does have the greater rate of change. Make sure you clearly label which one is bigger, this one or this one. For this case, it was the table. The fifth word is horse. Horse. So again, if you've written all this work, all the graphs, all the words, all the work, and have the words, show me on Wednesday, or paste your slides, and I will give you 100% on your 200-point quiz. Good luck.